All right, so welcome everyone. This is breakout session 1B, Mind the Mess, Preparing Survey Data for Public Health Analysis. This session focuses on what happens after data collection, specifically how to work with real-world survey data that may be messy, incomplete, or inconsistently formatted. The presenters will walk through why data cleaning matters, how to assess a data set before analysis, and practical strategies for cleaning and preparing survey data in Excel so it's ready to support sound public health decisions. Today's session includes two presenters. My colleague at Minnesota Department of Health, Abby Stam. Abby Stam is the Senior Health Informatician with the Minnesota Department of Health Office of Data Strategy and Interoperability. Abby fosters data and informatics literacy in local public health through trainings, data projects, and work groups. Abby has worked as a data manager and has taught others to clean and prepare data for analysis using R. Next is Dr. Lindsay Blair. Dr. Blair is an assistant professor in the Healthcare Administration and Public Health Department at Bellarmine University and serves as chair of the College of Health Professions graduate programs. She also serves as a librarian for Kentucky Local Health Department Academy of Science chapter. Dr. Blair holds a Master of Public Health and a doctorate in Population Health and Epidemiology from the University of Louisville and brings experience as a senior community epidemiologist and public health researcher. Her work focuses on the intersection of environmental exposures, epidemiology, and public health. She is passionate about using data to inform evidence-based decision-making and fostering collaborations between academia and public health agencies to strengthen community well-being. Well, with that, let's go ahead and jump in.
All right, let's do it. Thank you for that introduction, Annalise. All right, Abby, I guess we'll just get started with you.
Next slide, please. Lindsay's controlling the slides for us. In Minnesota, we like to begin with the Tribal State Relations Acknowledgement Statement for all of our presentations. The state of Minnesota is home to 11 federally recognized Indian tribes with elected tribal government officials. The state of Minnesota acknowledges and supports the unique political status of tribal nations across Minnesota and their absolute right to existence, self-governance, and self-determination. This unique relationship with federally recognized Indian tribes is cemented by the Constitution of the United States, treaties, statutes, case law, and agreements. The state of Minnesota and tribal governments across Minnesota significantly benefit from working together, learning from one another, and partnering where possible. Minnesota Department of Health recognizes, values, and celebrates the vibrant and unique relationships between the 11 tribal nations and the state of Minnesota. Partnerships formed through government-to-government relationships with these tribes will effectively address health disparities and lead to better health outcomes for all of Minnesota. In the Office of Data Strategy and Interoperability, we demonstrate our commitment to tribal-state relations by providing free assistance upon request and promoting health equity in data collection and use. Next slide. Annalise, would you please put the GitHub link that I gave you in the chat?
Yep,
All of the materials that we will be using today, you can pull from my GitHub account at the link that Annalise is providing. Just scroll down until you get to the part that looks like Lindsay's showing on the page. You want to download the 4 files under files used in our workshop. The bottom one is the slide deck, if you'd like the slide deck. The others are all files that we'll be using to illustrate examples. During this presentation, we will be talking about why to clean data, understanding your data set. We'll talk about how to handle duplicates, missingness, and outliers. And we'll talk a little bit about cleaning and transforming variables, including collapsing categories and creating new variables. And then, as time allows at the end, we'll talk a bit about handling open text data.
Which I'm excited about because I hate open text data. So any tools will be helpful. Okay, so I just want to start with this little chart here. Would you trust this data enough to make a decision with it? So just scan the table for a second and what jumps out at you? I see we've got an age of 999. That's either missing or really, really old. We've got a negative age there. I see a 4-year-old on the list. I have gender recorded as F in one row and male in another. And for smoker, we've got a yes, maybe, and only when I drink. So none of these are unusual in real world, especially real world survey data in public health. And this is exactly what we see raw survey data actually look like. And this is the core message for today. Bad data leads to bad decisions. So if we don't first clean our data, anything else downstream is already compromised. And this is my favorite saying, garbage in, garbage out. So no matter how advanced your analysis is, if your data is messy, your results will be misleading. And then that can lead to poor decisions about funding, staffing, interventions, and all of that can affect our communities. So most of the real work actually happens before you ever create the first chart or the first graph or the first dashboard. And data scientists estimate that about 60 to 80% of their time is actually spent cleaning data. And speaking from experience, Abby and I think that in public health, this is even more true because a lot of our data, I mean, it all comes from real people. We give surveys, there's case reports, we have Excel sheets that are passed around by email, or they're in SharePoint where different people can accidentally change things. So we all know that data is messy. So the goal of today is to give you some practical tools to make sure your data is good enough to trust before you ever run an analysis. So we're going to start with why data cleaning matters.
I took some ibuprofen.
These are some of the most common issues we see in data in public health. So we have missing or incomplete responses. You know, a lot of times people skip questions, especially if they're sensitive questions. We can have duplicate records. So maybe someone takes a survey twice, especially if there's an incentive involved, or the system may capture them twice. So you have a duplicate record. Sometimes we have inconsistent categories like we saw in that chart, and that is a classic problem. So we have the same idea here, male and man, but all different wording. And then there are a possibility of outliers and implausible values. So these should really always trigger a pause. Don't automatically delete them, but we'll talk about that. And then we had free text instead of standardized responses. So free text is good. It gives us rich context. But as an epidemiologist, and I'm sure we have a lot of those in the room, we know those are much harder to analyze. When we're dealing with survey data or even clinic data, there's typos and data entry errors. And they're not malicious, they're just human errors. And then we also have multiple ways of recording unknown. And this one quietly causes me a lot of downstream issues. So data cleaning is about deciding how to handle all these issues consistently and transparently. So when our data aren't cleaned properly, we end up with inaccurate results or misleading conclusions, which means that our estimates are biased. Maybe our trends look different than what they really are. Maybe we're saying, oh, our trends are improving, but actually we didn't clean our data and our trends are not improving. They're going the wrong way. So we don't want to misrepresent our communities based on bad data. That's why it's important that we have consistent reporting. So messy data down here at the bottom is the key here. Messy data leads to bad analysis, leads to wrong conclusions, leads to poor decisions. So has anyone, I'm sure we have lots of examples, but has anyone ever seen an example where bad data led to bad decisions or confusing reporting? So I think it'd be fun if you could pop some of those in the chat and we'll look at those at the end because, you know, garbage in, garbage out. I just want to let you know that there is a difference between data cleaning and data analysis. So data cleaning is everything that happens before you start answering questions. And then data analysis is what happens after your data is already trustworthy. So cleaning is about making the data usable. We fix any errors, we handle missing values, we remove duplicates. Sometimes we have to recode variables. And then the analysis is about making it meaningful. So that's when we use the data to find our patterns, we run our statistics, we create our charts and build our models, and we interpret our results. But even before any of that takes place, we have to start with understanding our data. And Abby's going to talk to us a little bit about understanding our data.
Begin. Okay, I had you download some files earlier. You want to start by opening the code book if you're going to follow along. In the code book, we have 4 columns. The first column is the variable name. That's the name that, that's the name that we expect to see in the data set when you open the data set. The label is what that name means. Since this is survey data, the label is the question from the survey. The type tells us what kind of data we should expect. Is it a date? Is it a number? Is it a character string? And then options, for when I create a code book, options will include things like any categories, if it's a categorical variable, if it's a number, are there certain restrictions on the number, like it can't be less than 0. I try to make sure to capture all of those under options so that they know what sort of values are allowed.
I like that. I love a good code book.
I do too. I actually enjoy writing code books. Next, we want to look at the survey, which you also should have just downloaded. It'll be one of the PDF files. This survey, we had entered into Alchemer and then downloaded the survey from Alchemer as a PDF. If you use Alchemer, that's an option. If you don't use Alchemer, some other survey softwares may have similar options, similar ways to do that. This survey, we included any validation checks that should have been there. We also included the short name, which should hopefully match the name in the code book if your person who built the survey and your person who built the code book were communicating. And it will show you what each question should have looked like to the person taking the survey. Next, we have the data itself. The data structure, you want to know first, how many survey responses did you expect? And is that how many rows you have in your data? If you don't, if there's too many, there might be some unexpected duplicates. If there's not enough, you might not have downloaded the entire data set or something might have been corrupted. Either way, you probably want to follow up with the data steward. You want to check if all variables are present and if their names match the names in the code book. Again, if they don't match, follow up with the data steward. Then look at the first maybe 5 rows of data. You want to see what kinds of values are they, and are they the values that match the options in the code book? You don't care so much what the values are. Is this number a number that looks like an age? It doesn't matter what the age is. If we want to do this in Excel, next slide, please, Lindsay. Thank you. There are a few options here for Excel functions that can help you to do that. In the data ribbon, Lindsay is much better at Excel than I am. As Annalise mentioned, I use R in most of my work. Under the data ribbon, you see both the sort and the filter options. If we click on filter, it will give us maybe chevrons next to each of the variables. If you click on the chevron, then you have the option to search and either uncheck or check things, or if you use the search feature, you can put in a partial name and then check all of the ones with the partial name, however you want to do it. And then when you click OK, it will only filter to those rows. Using sort, there's a couple different options for sort. One of them you can do just row by column by column. The other one, which is the one that Lindsay is showing us, you can do much fancier sort by first this variable, then that variable, and then click OK. And the last one is freezing panes. I tend to use Excel myself for only one thing, and that's looking at the data, and then I load it into R to do everything else. But I do use freezing panes a lot because it's helpful for looking at the data. What I'll do is I'll click on B2 and then go to freeze panes and select freeze panes. The thing I like about that is that it freezes both your report ID row and it freezes your variable names at the top, so that they're always visible no matter what row or column you're looking at.
Very helpful. And if you want to you want on other, you can freeze it there and then it'll freeze everything from the left. I love freeze panes.
And now I will hand it over to Lindsay to talk about duplicates.
Is it me? Okay. All right, let's go back and talk about duplicates. Okay, so let's look at these two people. What do you think? Are these the same person? They have the same date of birth. They have a similar name, Sarah Johnson, Sarah J, but they have different emails here. One's S Johnson at Gmail, Sarah J at Outlook. So they could be the same person, or they could be two completely different people. And this is what we mean by potential duplicates. They're not obviously identical, but they are similar enough that we need to flag them and then decide what to do, because duplicates can inflate our numbers and they can also bias our results. And that can affect prevalence estimates, coverage, it can affect funding and reporting. So we wouldn't automatically go in and delete one of these records. The first thing that we would do is flag the records that might be the same person, and then we review them systematically. So deleting duplicates is easy. Knowing which records are truly duplicates, that's where the real skill comes in, I think. So how can we flag duplicates? Well, we usually start by looking at variables that we expect to be unique. So we expect the full name and date of birth combination to be unique. We expect everyone to have different email address or phone number or the record ID, and also the survey timestamp. It is very low odds that two people would take the survey at the exact same time. So if two or more of these records match on these fields, then that's a signal that they might be the same person. And then IP address down here, that's a good example of something that we use with caution, because one household or clinic, if this information is coming from your clinic or your office, they might all share the same IP address. So don't be deleting all of those. Just flag some of those and look at me like, okay, are these duplicates or not? So this is very important. Duplicates are suspected. They are normally not confirmed. And Excel can help you find these potential duplicates, but it can't decide for you whether they're truly the same person or not. And in public health data, especially surveys and service data, people might use different emails or shorten their name or mistype something, or they could even submit a form twice, especially if there is an incentive. I know we did a harm reduction survey, and we got a lot of ones that seemed like the same person because we did have an incentive. So you want to definitely check for duplicates on that. So our job is not to automatically delete these, but they're to flag them and review them and then make a decision that we can defend, which is key there. Sorry, my heating pad is getting hot. Okay, so once we flagged potential duplicates, the next step is to review them manually and confirm whether they truly are duplicates. So sometimes we could decide to remove one record. So if one it clearly has incomplete or it's clearly test entry, then we can go ahead and remove it. Sometimes we retain both records, especially if we're not fully confident they're the same person, like Sarah J. And sometimes we might merge information across records, and I see this a lot in practice. So if I see this where they start the survey and maybe they finish the first part, and then they will go in and for some reason they X out or system error, and they go back in and redo the survey, and then the second survey will have all the outcome data. So we will merge those two instances into the same record. But there's no single correct choice here. It all depends on your data, your context, and your purpose. And remember to always record and report what you decide to do, because transparency is a very big part of data quality. And anyone using your data later should know exactly how duplicates were handled so that they can handle them the same. So really big there. Always report and decide what you want to do. So I'm gonna go ahead and show you how to do some of these in Excel. So if you want to open your CHA data set, I'm gonna show you some actual tools in Excel that can help us find and manage duplicates. So like I said, we wanna have a combination. So in here, we didn't ask any identifying information. So what I would do is I love this concatenate function. I'm going to name this column duplicate flag, and I am going to use the concatenate function. So equals concatenate, and this is recorded so you can slow me down later if you want to walk through it too. So I don't expect anyone to have the same age, the same gender, the same birth year, the same weight, and the same height. So I'm going to click on all those cells and hit enter. And then if I click on cell AI2 and see how it has this little dark box, I'm going to double click it and it will pull that formula all the way down. So I wouldn't expect any two people to have the exact same information there. So one way that I can find these duplicates is to click on AI, go to the Home tab, Conditional Formatting, highlight cell rules, and then duplicate values. We're going to highlight any duplicate value a light red and go ahead and hit OK. And we see there that, oh, look, we have two values right there that are maybe the exact same. And do we have any more? I don't know. We can put a filter on. I love Excel. It's my friend. So we'll put a filter on there, and I'm going to filter by all the reds. Those are the only two. So that could be a potential duplicate. Another thing that we can do is we could remove the duplicates. So instead of highlighting them, we could go to the data tab, remove duplicates, and then you can remove anything from that column that's a duplicate. I would caution against that because, we're just flagging them right now. You can remove them later. And then another cool function you could use, I just really wanted to show you how to use count if. It will tell you how many times this value appears in this column. So we are going to count how many times this exact value appears. And that's what our count if, so equals count if, and then you highlight this entire column, comma, cell AJ2. So you want to know how many times this 30 female 19956.33 occurs in this data set, and it only occurs one time. So if you double click that formula all the way down, we see, oh, see here, it occurs 2 times. So that's one way. I love the count if. It will return how many times that value. It just counts it. And then you could put it inside of an if formula like here, and instead of 1 or 2, it can return duplicate if the value is greater than 1. Otherwise, if it's 1, it will return a unique. So those are just some really cool formulas that hopefully come in handy when you are flagging potential duplicates. But what if data are actually missing?
Me again. Okay. If data are missing, there could be multiple reasons that data could be missing. They could be true missings where the person just didn't answer. They skipped the question because they found it offensive or they thought it was too personal or whatever. It could be that it was a system missing or a skip logic missing where they never saw the question because of the way the survey was designed. It could be a prefer not to say where, well, they answered the question, they just didn't give you an answer that was helpful for you. All of these can be handled differently depending, as Lindsay was saying, on what your purpose is and what you're trying to accomplish. If you're interpreting missingness, to give an example, prefer not to say is not the same as just leaving it blank. And some possible interpretations I list here where one could mean none of your business and the other one's like, I'm just not dealing with this question. I'm just not dealing with this whole survey. Who knows? And skip logic generally you would interpret as not relevant because they never saw the question. What can you do with missingness? It depends. I know when I was in school, they did a lot of complete case analysis. That's where you removed any records that had any missings in any of the variables you were interested in, but that eliminates a lot of data that might be really helpful. So there are other things you can do. You can set missings to NA and then handle them specially in your analysis, or you could impute them, which I think Lindsay will touch on later. And then there's different ways that you can exclude or weight or something the skip logic missings. Excel school tools to handle missingness. There's another count one, count blank will tell you how many of these values are blank, and then various if statements.
Oh, sorry. Sorry, Abby. I wanted to show them the count blank.
Oh, yeah, go for it.
Okay, so equals count blank. Abby, can you walk us through what this formula is doing?
Yes. So are you choosing the doctor through the other?
Yes.
Okay. So what we're doing is the doctor's office through the other, if you have looked at the survey, which I'm sure none of you have had time to do, that is a select all that apply question. And the way that I created this toy data set, this is not real data, is that they could select up to 3, just because that was the way I coded it. So I want to know, did they select all 3 or did they select only 1? If they didn't select any, that's a true missing. They didn't answer the question. And so by doing the count blank, we can figure that out.
So this tells us how many are blank. So this one there are 5 blanks, so they just chose 1. Oh, and what about how you do the reverse, Abby? I like that.
Oh yeah, if you want to do the reverse, so you know that there's 6 options and you want to see how many were answered, then you do 6 minus count blank, or
That
whatever
tells
your
us.
total is.
So 3 were answered and 3 were not. Yeah, I like count blank. Okay. Okay, sorry. And then those if statements that we talked about earlier.
Yes. And now I'll hand it back to Lindsay to talk about outliers.
Okay, so outliers are values that fall well outside of what we reasonably expect for a variable. So here in this example, we're using adult height as a simple example. And these are just illustrative ranges. I know we have lots of people that are men that are taller than 6 foot and women that are taller than 5'7", but these are just for illustrative purposes. So if we see a value like 4 feet tall for someone, that doesn't automatically mean it's wrong, but it should catch our attention because it is outside of what we would normally expect. So outliers are signals. They tell us to pause, ask questions. Don't immediately delete your data. So once we've identified an outlier, the next step is evaluation, not removal. So first we would ask ourselves, is this value plausible? So that might mean we check the literature or known biological limits. And then second, we say, well, could this be a data entry or measurement error? Think about units. Maybe they entered feet instead of inches, or there was a typo, or there was a device issue. And then third, can the value be confirmed? So sometimes you can verify it against another source. So a lot of times when we go out into the community, we have them write down their survey, and then someone within the office will enter it into our data collection system. So I know that we've done this several times. We're like, wait a minute, they weigh 792 pounds. That can't be right. Let's go back and pull their file. Oh no, they weigh 192. It was a typo. So then that can be corrected. And then finally, does this represent a real but rare case? So if someone really was 4 feet tall, should we delete them from the data set? No, of course not. That's why we investigate first and we delete second, because removing outliers without justification, that can introduce bias, and it can even mask real population variation, which we want to retain. So once we've identified an outlier, what do we actually do with it? Well, the first, if the value is plausible, we just retain it. But if you determine the value is the result of a data entry or measurement error, then you have a few options. So you might correct the value if you verify the true value. If it can't be confirmed, you might set it to missing so that it doesn't bias your results. In some cases, you might impute a value. I've done this on several occasions. That means that we estimate a value using a defensible method. So a lot of times I have taken the median value of something, especially if I'm using census data and it's was entered incorrectly, I'll just take the median of that and impute it into that field. And then another option is capping, or what we call Windsorizing. And that's where extreme values are replaced with a specified upper or lower limit. So that will reduce the influence of those outliers while still retaining observation. So let's just take BMI, for example. If maybe the upper limit is 47, but you calculate someone's BMI as 90, you could cap it at 50. So instead of 90, you change it to 50, and so you cap it at 50. So you still retain it's a high BMI, but it doesn't influence your data as much. So I definitely want to make clear that all decisions should be documented and justified. I know we probably said that 1,000 times. It's very, very, very important. Transparency is key. And you don't want someone to ask you later and then you go back and be like, I have no idea what I did with that. So make sure that you document everything. And then these are some tools that can help you flag outliers, but your professional judgment will determine what you actually do with them. I'm going to open back up Excel and I'm just going to, we talked about sort and filter, conditional formatting. I want to do some pivot tables. So I love pivot tables that help you really see your data. So we're going to click on, I don't know, this chevron or this triangle in the left corner here and highlight the entire field. And then we're going to say insert pivot table. You have two options. You can insert that pivot table in this worksheet, but I like it on a new worksheet so that it's clear. So I'm going to go ahead and insert it in a new worksheet. Oh, I don't know what I've done. Oh, it's not going to let me. No, I want to show you. Dang it. I don't know why it's not letting me.
Can you just show it on one variable?
Yeah, probably. But now when I download the data set again, why does it always happen to us this way?
You may have to make the list format it into table, because right now it's just alignment.
You should be able to. It doesn't have to be in a format. It does work in a table as well. We're just gonna download Mockchaw Final 3. Okay, yay! I don't know what was wrong with the other data set. I have to figure that out later. But it works now. So you do the pivot table, and I want to look at age. Are there any age outliers? So I'm going to drag the age variable into my rows and also the values so I know how many, well, that's the sum, but I'm going to change it here to count. I want to know how many people actually have those ages. Oh, it looks like one person has an age of 8, but we limited our survey to those 18 plus. That could be data entry error. We have to go back and check that. And if we scroll down, our upper range is 121. I don't really know of anyone in our counties that is that old, but that's not to say that they're not. So what we would do with these outliers is we could confirm them by calculating an age category from our birth year field that we asked them and today's date. So I'll show that a little later. But keep in mind that we have a 120-year-old and an 8-year-old, and we will try to confirm those later. All right, get rid of all those. Oh, and this one. Okay. Okay, so those are our outliers. So what about recoding our variables? So sometimes recoding means, well, not sometimes, always, recoding means that we're modifying an existing variable. We're not creating something new. We're just changing how the values are represented so the data are usable, they're consistent, they're easily analyzable. So for example here, survey responses like male and female, when you go to analyze them, they might need to be recoded to 1 and 0 so that they can be used in statistical models or packaging softwares like SPSS or R or SAS. The same goes for yes/no variables like smoking status. We can also recode to standardized messy categories. So for instance, the county field was a free text. So someone entered Jefferson all lowercase, someone entered Jefferson all uppercase, but we can use Excel to standardize it using the equals proper formula. And then also Likert scale responses are another common example. So we would turn strongly agree into a numeric value that lets us summarize that ordinal variable. So recoding is about clarity and consistency. We're not actually altering the meaning. So let's go back to our Excel. We'll bring up CHAW 3. Go back to our data, and I want to recode gender. I want to recode female, male to 0, 1, just for an example. And I did it within this field yesterday, and Abby yelled at me. So I'm going to create a new field. So I'm just going to copy gender and insert copy cells there. So it's going to be gender new, which Abby was right. So let's just use the Control F function. We're going to go to the replace here. We are going to replace female, and you want to start with female because if you replace male first, it's going to replace the word male in the word female with a 0. Or yes, so replace female first. Let's make it a 1 and hit replace all. So now we have there were 89 females, and now we've replaced them with a 1. And then you can go in and replace your males with a 0 here and replace all. And then we could also replace prefer not to say with 99 or whatever code we're using for our missing value. So maybe I didn't go that right, but that's one way that you can do that. And then if we have here, if we look at our counties, we have some of them are all uppercase, some of them are not. So then we would use, create a new variable here, and this is where you use the proper function, and it will change it. So if this was, say, Stevens here, it would return it as Stevens proper. So I love this function. And then if you want to get rid of the formula, this is what I use, helpful hint. So I bring it all the way down, and then I just hit Control C, and then I right click and replace 1, 2, 3. So now there's no longer that formula there, and it's easier to manipulate. So those are just a couple ways that we can recode variables in Excel. But what if we want to collapse some variables? Abby, you want to talk about collapsing variables?
Sure, yes. There are 3 main categorical variable types that I tend to look at. The nominal ones are the ones like gender, where no category is above or below another category. Ordinal means that there is some kind of order. I used to teach in public school, and my students' grade levels would be in ordinal categories. Interval is named number ranges, things like age groups, especially if you're doing things where you want to join with census data. You would be creating age groups first before joining the census data.
Oh, sorry.
No, that's okay. You can go.
Okay.
There are a few definitions to introduce you to in case you're not familiar. One of them is cell count. Cell count is huge, especially when you're dealing with public health data and you have to worry about confidentiality and privacy. We don't want to reveal any data where the cell count is too small, because there's a danger it could be traced back to the person. So we want to know if we are looking at anything that includes very low cell counts. Also, when you do your analysis later, a lot of statisticians don't like low cell counts because it can reduce the power and the strength of whatever statistics you're calculating. Small numbers, again, that's where what I was just talking about, where it's below the minimum threshold. If you work with data stewards, very often data stewards will have specific thresholds that they say do not show cell counts below this, or do not calculate rates and display them with cell counts below this. And very common ones, for example, are below 5, below 10, below 15. And check with your data stewards and check with your statisticians if you can. Collapsed categories is where we're combining 2 or more categories, especially so that we can handle small numbers, but also if you have a lot of categories, if you are looking at the options in the mock survey of all the different genders, maybe you want to try to combine some of those, because there's a whole lot that not very many people are choosing. Next. Here I'm giving an example of a Likert scale. Here first we'll address small numbers. We have poor is only 4 and fair is only 8. 4 would be too small for every data steward I know. Fair would be too small for about half of them. So we're going to combine them into a count of 12 and just call it not good. It's below good, and it's a new category. And we can also combine categories because we want to interpret our results more easily. In this case, maybe we're just interested in not good versus at least good. And we want to see what's the ratio of people who picked at least good. And we want to see if that goes up over time or whatever we're doing. Then we might want to add good, very good, and excellent together, and then do a ratio or a percentage to find out what % of our respondents reported their health was good or better. Next. Here's a few commonly collapsed categories. How you collapse the categories depends on what your goal is, what your purpose is, especially when you start getting into things like collapsing genders and collapsing races. What you choose to collapse and how you choose to collapse it can change the interpretation of whatever information you're sharing. So be aware of what you're doing. Consult with people who are in the groups that will be affected if you can. And now I'll hand it over to Lindsay to talk about creating new variables.
Okay, so recoding, we're just recoding. We're not creating anything new, but when we create a new variable, we are deriving new information from it. So we're often combining multiple variables or transforming raw values into something that's more meaningful for analysis. So a very common example is creating age groups from age. So rather than analyzing every single year of age, we might group people into categories like working age adults, older adults. It all depends on our research question. Another classic example is calculating BMI, which we calculate using both height and weight. We also frequently create composite or risk scores. So maybe we ask about multiple health indicators like smoking status, chronic conditions, access to care. So if we want to create a risk score, we can create a new variable to summarize the overall risk. There are also some tools in Excel to help with this. So the first one, this is a formula. It's creating a binary yes/no variable from either from messy text responses or from drop downs that have more than one response. So I just kind of want to explain this formula before I show you. So first, that search yes Y2, that looks inside that cell Y2 and it checks whether the word yes appears anywhere in the response. So it doesn't care if the response says yes, yes trying to, yes sometimes. As long as the word yes is in there, it finds it. Next, that is number checks whether that search was successful. So if Excel finds the word yes, it returns a number 1. If it doesn't, it returns an error. So finally, that if statement tells us if the word yes appears anywhere, then label the response yes. Otherwise, label it as no. This allows us to standardize those free text responses into clean binary variables that are way easier to analyze, which I like way more. We can also calculate age from year of birth. So remember, we had an 8-year-old and a 120-year-old, and we kind of want to confirm that. So we're going to use the year of birth and either today's date or the year of that they completed the survey. You can use that too. Just caution that this could be off by 1 year depending on the date of birth. So I'm 41, but if I took the survey right now, it would say I'm 42. My birthday's not till later. Just know that, but it's only off by 1 year. So that'll still tell us whether the 8 or the 120 is an outlier. And then this formula down here calculates BMI using weight in pounds and height in feet, which is what we asked, because that's, those are commonly the variables that people, I know my weight in pounds and my height in feet, but I can't tell you what it is in kilograms or meters. So the BMI, the core BMI formula, it is calculated by dividing weight by height squared, but we need that conversion factor since we didn't ask kilograms and meters. So that number is the 703. That is our conversion factor. And then this W2 is our height in feet. We multiply that by 12 to get it in inches, and then we square it, and that will give us the BMI. So I want to walk you through that in Excel, but I thought that it might make more sense if I explain some of these numbers first. So let's calculate our trying to lose weight field. So we'll just name it lose weight. So that would be the equals if is number. So it's going to search our column and it's going to look for the word yes, and we put it in parentheses. And our column is this one here, AA. Yes, I want to lose weight. I think that's it. It's going to look there. We're going to do 2 parentheses. And if it finds it, I want it to return the word yes. Otherwise, I want it to return the word no. So let's look at this one here. It returned yes. And if we go to AA, it says, yes, I want to. Down here, it says no, they prefer not to say. So we could also set that to missing if we wanted to within the formula. And then here, yes, they're trying to as well. And it calculates yes. So it works. So now we have all these different options for yes, we want to lose weight. Yes, we're trying to lose weight. And no matter what they said, it returned a yes if the word yes is in there. So now let's calculate our age. Age new. So we're going to calculate our age from, let's just use today's date. That today formula captures today's date. And I think there's another one here, minus our birth year. So this person should be 63 plus or minus 1 year. And sure enough, they're 62. So I just want to double check here. Let's filter for our 8 and our 120-year-old. All right, so 8 and 120, and I must not have pulled the formula all the way down. But now I'm committed and I want to know what it is. So he's 29. Okay, that was a calculation error. And they actually are 120. We really do. So this 8-year-old is an error. They're probably 28 years old. And this 120-year-old, I guess they are maybe the oldest person in the county. So if you want to clear that filter, you can hit clear. Oh yeah, see, I didn't pull that formula all the way down. I got ahead of myself. Okay, let's calculate BMI. So BMI equals that conversion factor of 703 divided by our weight, which for that person is 0, divided by our height times 12 squared. I hope I got all these parentheses correct. And no, I did not. Equals x squared divided by, I'm missing a parentheses here. There you go. I love Excel. It tells you when you're missing something. And if we pull that all the way down, here we go. This person had a BMI of 0 because they didn't have a weight. This person has a BMI of 21. That sounds about right. 35. Yeah, our formula looks really good. So now we've created a binary variable. We created a new age variable to confirm whether our outliers were real or not. And then we've calculated BMI from height in feet and weight in pounds. And now our really cool exploring open text data.
I enjoy open text data. When I'm exploring open text data, I use what's called regex or regular expressions. This is special character patterns that you would enter in order to identify specific patterns of characters in your text. It's very powerful. It is complex. If you want to learn it, it takes time and effort, but you can do amazing things once you do. I really like it because especially if you're looking at open text data and you want somebody saying, hey, will you share that data set with me? But you want to make sure that there's no personal identifiable information. You can use regex to check for things like phone numbers, social security numbers, email addresses, mailing addresses, even proper names potentially, so that you can make sure to remove all those or redact all those before you share the data set. Another note is that regex does differ across different statistical softwares. So the code that I show here is the code for Excel, which I had to look up because the code I know is the code for R. So if you're coming from one language, be aware you might need to use slightly different regex code between the languages or between the softwares. Also, an issue with regex in Excel specifically is that not all versions of Excel have the regex formulas built in. For me, my desktop app does not have it, so I have to go to Excel Online if I want to use it. Lindsay, would you please copy or wherever you pulled from the email one and run the email one on the AJ column?
Yes. Okay. Reg extract. And then on the AJ column.
Mm-hmm.
Okay. Let me see if I copied it right. Let's see. It looks right.
When we tried it yesterday, we ran into issues with the double quotes didn't translate correctly between PowerPoint and Excel. So in this case, we have one that does have an email address. So we may want to investigate or remove that email address if we're going to be doing anything specific with that particular response.
Yeah, I love that. This will come in so handy. And I had never used it before, so I learned something new today too. Thank you, Abby.
You're welcome. And I think that is all that we have.
Yes, I want to thank the Kentucky Health Department Association and the Kentucky Local Health Department Academy of Science for making this available for us and giving me the opportunity to share it with you today. And then here is our contact information. Feel free to reach out if you want if you want to know anything about what we talked about today. More than welcome to work with you. I love data analysis, so you'd make me very happy if you wanted my help. And I don't know about Abby, but I'm volunteering you, Abby.
I was a data manager for many years. Much of my life was data cleaning.
So good. So I guess we'll open it up, Annalise, to questions. Or maybe it looks like there's maybe some in the chat.
Yeah, thank you guys so much. That was a great presentation. I really enjoyed it, and I feel like I learned a few things in Excel. I feel far removed from it, but now I kind of want to get back into it. That was really cool to see. Um, so we did have a couple questions in the chat. Let me scroll to them. Abby did kind of respond to one of them, but Lindsay, we may want to pick your brain on this as well. So we have a question. When appropriate, can you speak to weighting? Example. So 8 responses are women and 2 are men. All women say the favorite ice cream is chocolate. All men say the favorite ice cream is vanilla. Clear 80% chocolate, 20% vanilla is not quite correct. So any tips on weighting properly? Abby did say it depends on what you are planning to do in your analysis. In this case, I might share stratified results rather than weighting. Any other thoughts on that?
Yeah, that's possible too. You could always weight based on the correct, I'm trying to find the question, based on the correct distribution. So if just for example, if there's supposed to be 50-50, but you have 30% males, maybe 70% females, you weight those males more and you weight those females less so that it evens out to be 50-50%. So their response would be weighted less than the, well, I forgot which way I said, but
Based on the population.
I believe
yes,
that's
based on
called the
yeah.
raking method. I can actually
Yes.
drop in the chat just an article I came across with a bunch of different methods for weighting. So hopefully that
You
helps
are
too.
amazing. If we get to vote for best moderator, you are it.
Oh, well, thank you. All right. So what, another question that came in, what do you recommend when someone completes only half of the survey? So half of their responses are blank or missing.
Well, I guess it depends what half. So, a lot of times, if it's only demographic information, that really doesn't tell us anything. We just get rid of them. But if they've also completed some of the outcome uh, measures, it depends. If I have a lot, Abby, you can correct me, see what you do. But if I have a very large sample size, I will go ahead and get rid of that and do a sensitivity analysis later. So I'll do an analysis with everyone included and then analysis with only those that I included and did not remove. And if they're comparable, I stick with my analysis of the people that I only included.
And when you do that, make sure to document it and to note how many you left out.
Yeah, exactly. So that's definitely one way that you can do it.
Always document.
Always.
That's the one key takeaway that I think everybody could take from your presentation. It was excellent. Good advice.
I guess also on that, Annalise, if I have a low sample size, I will retain. I really like to have one sample size for all of my data results. But if I have a low sample size, I will include the outcome measures that they did do, as long as the ones that they didn't has no influence on that data. I will include them. And I always make sure that I let the reader know what my sample size is. So it includes these people and I've excluded these.
And there's some rules if you get into imputing data and handling missingness regarding how many of the variables for any specific record can be missing in your analysis.
Yeah.
Great. We just got another comment in the chat. So one thing I ran into in our last SHA survey was a question that said select one, and online the survey software only allowed one choice. But then when folks filled out the paper version, some would select more than one, and I struggled with what to do. Any advice?
We had the same exact issue in Kentucky, and it definitely throws it off. So you can include everything and you make it clear that it was select one, but several of them did not follow those directions. You can also not include those, but I would never just pick which one. Like I would never do that. So you either include them all or you include none of them is would be my advice. Abby?
Yeah, you'd want, and if you were going to include everybody, then you'd probably want to think about some way to know which ones answered only one and which ones answered
Yes.
both within
Yep.
your analysis so that
Yep.
it doesn't look like the only ones were just failing to answer part of it.
So good. I would flag those and do a sensitivity analysis, especially if you're going to publish this later or give it to stakeholders. Like these are the ones that only selected one, but when we include those that selected everything, these were the top choices.
Mhm.
Yeah, that's hard because you can't do the skip logic or anything on those paper surveys.
Great, that was great advice. Any other questions?
I have another question.
Yeah.
If you're administering a survey with an incentive, what do you guys do for like filtering out if it's a potential bot or if somebody was like rushing through the survey, not answering accurately because they just wanted the incentive and so their answers might be like fraudulent because they were just trying to get to the end.
Yeah. So if it's a bot, I know when we use our Alchemer surveys, we include that IP address and you can tell that it's not like if this was supposed to go to Hardin County, Kentucky, and you're getting responses from Israel or somewhere overseas at England, okay, those are probably a bot. Let's not include those. We do not include those in our analysis. We also have, in Alchemer, I know it's other software programs too, but we use reCAPTCHA. So that allows us to kind of get rid of those bots before they even happen. You have to verify that you're human. So reCAPTCHA is a really good tool, and I'm happy that Alchemer has that we can put that in there and kind of try to control those AI bots. Abby?
I've never experienced that. So how does that even happen? Do you know? Like how do
Well,
bots?
yeah, it happens a lot with those online surveys. I can't speak to how it happens. I don't know. Elizabeth, do you know anything more? I know you're not a presenter, or Abby.
I have not dealt with online surveys directly, at least not in that way. I know Annalise has done that a little bit. I don't know if Annalise
Yeah.
is willing to speak to it.
The CAPTCHA, that's common in a lot of different survey tools. I was also thinking in terms of, I haven't really come across a bot issue. Luckily, most of the surveys I've worked with have been more internal, so that's the nice thing about that. But the looking for individuals who are quick to answer a survey, so basically go through a survey and just answer the same thing over and over again. You can typically detect those through an outlier test. So you can run some sort of outlier test and see, we see that one individual put the same response across the board. You can typically rule them out and remove them from the analysis.
Yeah, Logan had a great response. She looks at IP and time between submissions in milliseconds. So, and she also looks at the patterns and the responses, like one different choice between rows looks cascading when you zoom out in Excel. That is a great idea. That's a good one. If you look and see those submission times are within milliseconds of each other, then I would go and look at the responses. That's a great idea.
Great. Looks like we got quite a few responses to that. Oh, sorry, I saw one come through, but oh, there we go. If
There were-
conducting an in-house survey for your department, would you recommend all questions be optional to respond to, or can some questions be required? If so, what would you recommend to be required?
If you are going to make all questions required, I would, and I know our IRB recommends you always add a prefer not to say on ones, especially that could be sensitive. So maybe you require it, because that will help you know, okay, did they just skip it or did they not want to tell me? So definitely add a prefer not to say on all of them. I like requiring questions that are important. Like if I'm really looking towards this outcome measurement, I'm going to require that question. I don't want you to just blow through my survey, especially if there's an incentive, and skip the meat of what I want. So I definitely make those required. But if you are going to make some of the demographics and things like that required, if they're important to your analysis, add in that prefer not to say so that you know whether they skipped it or whether they just that's sensitive to them and they don't want to let you in on that information.
That is a really great recommendation, specifically if you're working with demographic variables. So perfect. Did I miss anybody? Another question in there? Don't think
There was
so.
another comment about the bots, but I don't see another question.
Yeah, it looks like maybe some issues with Qualtrics and bots slipping through the cracks.
Yeah.
Try Alchemer. Maybe that'll be better.
Try Alchemer, use reCAPTCHA.
Yeah.
See if Qualtrics has reCAPTCHA.
Yeah, they
I have
probably
no
do.
idea if it does or not.
Yeah. All right. And I'll throw out a question. So just curious, but how do you guys balance cleaning data thoroughly while still preserving transparency and avoiding overcorrection?
I use sensitivity analyses a lot. I know when I first started, I was like, gosh, I don't want to do an extra analysis. But then once you really get into the clean, especially so when you don't require or prefer not to say, you have all these missing values and it's so hard to decide. You know, you don't want to throw all the other good data out, but you don't want to necessarily impute them incorrectly. So I do a lot of times I end up doing two analyses, one with the ones that I've imputed and one with not including them. And then if those are similar, I always go with the cleaner, the more simple version, the cleaner version. So I use sensitivity analyses a lot, and it adds to your analysis, but I think it adds power and strength to your data.
What I'll do is I've done more preparing data for specific projects than for research. I've done some research. What I'll always do is start by creating a minimal data set that has only the variables that I'm interested in. And then I don't even look at any other variables at all. I just focus on those unless I need like one other one to check for deduplication or something. But then once I have the variables I want, I make sure that I know exactly what I'm going to use them for. I do look at sensitivity analysis. I'll also look at things like small numbers. And do I have enough numbers in any given cell to have the statistical power that I need? And if I don't, then how can I address that? And I will probably go track down a statistician friend to talk it through with them because that's not my strength. If you have statistician friends and data manager friends, talk to them. and run by them whatever you're thinking of doing.
That's my favorite thing about research. You're never in a silo. You're never by yourself. You always have someone to bounce ideas off of. I love that. And that's great advice, Abby. You.
Hey, can I ask a
Abby,
quick question? Oh, go
I
ahead.
don't know, Dr. Dahlia, is it a hard one?
But
go ahead, Dr. Ball.
I did hear somebody else talking. Was it you, Annalise? I don't want to
Yep.
interrupt.
Go ahead.
Okay. So one of the things I've run into at a university is that sometimes you have newer researchers or students, and when you're talking to them about data cleaning and analysis, they want we do this every time. Like when I run into this, I do this. And I just went back and forth not that long ago with well, yeah, and in that case, that's what we did. But in this case, we're doing it like this because of this. And so helping newer researchers and students understand that the way we deal with data varies. It can be like there isn't one answer that fits every situation. And I know, like Lindsay, you've got students, and Abby, I don't know if you also interact with students, but you certainly interact with newer researchers. How do you help newer to the field folks understand that it depends nature of the work and the document, write down what you did and why. That's what matters. But how do you help deal with sort of it's not the same every time?
I'm not doing teaching at the moment, but I'm doing some informal mentoring. And one of the things I really like about mentoring is I can sit down with people and say, what exactly are you trying to do? Let's talk through what your options are and which one makes the most sense.
Yeah, that's good. We always look at I see this a lot with my dissertation students. And I'm like, what is your overall goal? That's going to determine whether you keep these, whether you impute them. And there's no correct. I wish it's like with parenting. It's like, what do you do every single time they disobey? Like, it's always different. It depends on the context. And it's same with your handling your data. There's never, but I always like Abby, I'm like, what is your overall goal? That's going to determine, do we get rid of those? Do we keep them? And it's definitely going to be different, but you just document. I always ask them, what'd you do with that? And they're like, well, go back, restart. Like,
All right, we'll give just a second here to get settled. All right, looks like our number is slowing down. So welcome back, everyone. I hope you enjoyed your morning breakout session. I know I did. I was saying that I'm sad that I don't have more time immediately to go play around on on the dashboard. So I hope that you found something and you noted something down that you're excited to learn more about, or a next step, an action step that you're going to take. We are going to go ahead and transition into lunch. So we're only going to be here for a minute, but I just wanted to say again, thank you for moving into breakouts and navigating the Zoom technology with our team. And we are going to be doing this again this afternoon. For now, we have a lunch break of about 45 minutes. So this is your time to grab a snack, move your body, take care of any pressing work things, and we'll start up at 1:15. We will be starting back in the main room together with a featured session, which I'm really excited about. I mentioned before, it's a couple of my colleagues from the Wichita State Community Engagement Institute. I'm looking forward to introducing them after the lunch break. And if you are sad that you missed one of the sessions this morning because you can't be in two places at once, as a reminder, we are recording sessions and they'll be uploaded to the local health department Academy of Science website in the near future. So don't worry, I'm going to have to go find some of those recordings as well. But I don't think there's anything else. We're going to leave this room open. Our team is going to also go off camera, grab some lunch, move our bodies, but we will be checking in, getting closer to the time. So if you have questions, drop them in the chat and we'll get back to them as soon as possible. And if not, I will come off camera after I get something to eat and move around a bit, and then you'll know that I am